Once we dive into chemistry, it's impossible not to see it everywhere. The perfect example? A kitchen. It's an organic chemistry super lab. So, why don't we move there? Now that we are in our kitchen lab, we can finally discuss some chemistry. Cooking food changes it from a chemical standpoint. From oxidation of pigments, to the Maillard reactions, to many others. We can use spectroscopy to see all of these changes in real time. But first, we need something to analyze, so let's get to cooking. Combine ultraviolet visible light spectroscopy with chromatography, and you've got the perfect tool, high-performance liquid chromatography. Raw onion HPLC analysis shows strong quercetin glycoside peaks, heating suppresses them, and the chromatization produces a broad Maillard baseline. The UV-vis confirms this. 255 and 370 nanometers flavanol bands fade, and 420-450 nanometers absorbance grows, indicating melanoidins. Cooking reveals the same transformations we study in the lab. From reactions that create color, flavor, and texture at a molecular level. Spectroscopy just lets us see what taste looks like.